Hello. In this set of presentations in decision diagrams in the ADD Lib framework, we are going to focus on the ADD Lib framework itself. This is a framework that's used to build decision diagrams using a user interface. There's also a Java coded version, but today we will focus on the user interface. So this is a Java library for algebraic decision diagrams, code generation, and layout definitions. It is developed by Frederick Gosson and Tiziana Margherita. It is a Java framework for decision diagrams, new binary decision diagrams, zero suppressed decision diagrams. We haven't discussed them in the previous lectures, but essentially they are binary decision diagrams with all true edges pointing towards a false terminal being removed. So only true edges going to true terminals are left, and false edges going to false terminals are left. So they're almost like a more compressed version of binary decision diagrams. We then have algebraic decision diagrams, which again are similar to binary decision diagrams, except you now have real values as the terminals. Instead of using the Boolean operators, you can now use plus, minus, multiplication, min, max, etc. And then you can also have custom decision diagrams, or XDDDs. So you can actually define your own logics, such as Klein-Priest logic, which has true, false, and unknown. So you can have fuzzy logic. It has type safety for decision diagrams. So that means only operations that can be performed with a certain object type are allowed to be performed. So you won't be able to perform an operation as invalid for a certain object type. It is an easily extensible framework, and it is a seamless adaptation to custom algebraic structures. So this means you're able to create such algebraic structures as groups, ring-like algebraic structures, such as fields and rings. You're able to produce lattices, such as a Boolean lattice or bounded lattice, and other similar algebraic structures. The ADD Lib environment itself is composed of 3 separate development environments. So the first underlying core environment would be the Cinco SCCE, which is a meta tooling framework, which essentially means this is an integrated development environment, or IDE, for the quick and easy development of domain-specific graphical modeling tools. So it's a generator-driven development environment with domain-specific graphical modeling tools. So essentially we can create our structures and logic projects through Cinco, which will then be passed to part 2, which is the mIDEs, which is our Eclipse development environment. These are mindset supporting approach. So this means that they use domain-specific languages, or DSLs. So this is a low-code environment which essentially uses predicates based on the domain logic on which you're using. So you won't basically have to code using a programming language. You can build structures using domain knowledge of the system, and then from there generate code automatically from these set models. This would then go into the third part, which would be Java application. This is developed by programmers or developers. Currently, we can generate code in Java, C#, JavaScript, C, C++, Dot, and I believe a couple of other languages. So, in essence, in Cinco SSE, you define your logics, so basically Boolean, fuzzy logic you need to build your models. From here, you generate your Eclipse environment. And within the Eclipse environment, you then create your models, which then code is automatically generated from, and then your model is applied as a classifier or whatever it is going to be used for. Here you see a visual example of the infrastructure or architecture. At the bottom of the corner is CUDD or C, C++ libraries. ADD Lib is essentially a Java wrapper of the CUDD, so it allows programmers to program in Java, which is then translated into C or C++ before being compiled. On top of all that, you have your visual tools, such as M3C tool. your BDD tool, which is what we use, the binary decision diagram visualizer, which is actually called dot viewer. And you can have min-max logic DD tool, color DD tool, and etc. etc. Basically, these are just your visualizers, but then it goes down into Java code and then goes down again into C or C++ code. Again, we go into our language overviews. So we have our Xtext, Java, Xtend. Xtext and Xtend are basically graphical tools that can be applied with Java. Then go over to the in-meta mIDE, which again is the mindset IDE or domain specific IDE, where we create our algebraic structures, and again with our Java. Which then goes into Synco, where we create our meta graph language, MGL. Again is our logics and features that allows us to create our predicates, nodes, graphs, etc. And then that goes into the mIDE itself, where we have our predicates, decision diagrams, or compositions of decision diagrams, and gets generated into Java code. We'll move again into our email classification example. So our problem is organize emails in the inbox to find urgent emails. Again, this is similar to the example we used in part 1 of our slides. So the developer must build the specific Java program. So we still need developers in this environment, but they focus purely on the Java application itself, while the domain specific users would model decision logic with their own preferred mindset or domain specific instances. mIDEs are developed for domain experts to imply. So again, it's a low code environment that allows non-programmers the ability to build systems. Mindset supporting integrated development environment. Popular mindset that we use is decision diagrams, as they're easy to implement and easy to visualize. Allows for partial evaluation. This essentially produces or optimizes new programs which run faster than the original program, but preserving the same logic and behavior. They use domain specific languages, again based on what domain you're working in, be it business, medicine, networking, school teacher, etc., etc., and domain specific optimization, which again, optimizing your decision structures. The modeling tool itself in the ADD Lib, this is from tips environment. So in the top left, you will see modeling tool for the decision diagrams. So trusted sender is on the from gov. High pointer goes to true, low pointer goes to in address book, low pointer goes to false, high goes to true. This would then go into the position of the 1, 2, 3, 4 decision diagrams. The or and they take 2 predicates or another operator, and the not operator can only take 1 single predicate. And again, it all goes up to a single connective binary operator, which goes to the function root. If this is not here, then this whole graph is unreachable from the root, and this will be displayed in a validation window, which is usually displayed in the bottom left corner. This is a valid construction. You'll get a green tick which says checks are passed and everything is reachable. You can then generate the code. Code generation. Final composed decision diagram, as we saw in the previous slide, can be used as a model to automatically generate code to be used by an application. Now there are code generators available for Dot, Java, JavaScript, C#, C, C++, Python+. There are more being developed. You can also create code generators, which is the one you can see here. This is a Java code generator. You can create a generator and generate a generator, which is interesting. So this is the code generation process. You see the binary decision diagram. This will then go into the composed decision diagram. And when we generate the code, it will be converted into Java, which you can see here on the right, which is generated code, which can then be used within our Java application. So it's an end-to-end solution. So we can define our structures that we're going to use, be it Boolean structures or reals or fuzzy logic or in the Synco environment. And then in our mIDE for BDDs, we can create our binary decision diagrams, algebraic decision diagrams, or a custom decision diagram. We compose these, generate the code. These can then be used within the Java application, which can then you can see here as an example in our email simulation. So this is, say, a Boolean decision diagram. Say we have an optal one on the left, and we have our own version on the right. So you can define from start to finish in a low-code environment. Let's say BDD, we want to go over to an algebraic decision diagram, over to an ADD. So urgent emails may not be distinguishable through Boolean logic, so true or false may not be enough. There might be uncertainty. Maybe we're not certain whether something's urgent or not. There might be an 80% chance. To represent uncertainty, we'll require a different style decision diagram, an algebraic decision diagram. So the solution is the evolve or mIDE. So we want to go from Boolean true false to reals, 0 to 0.1. So let's say a probabilistic logic semantics. So probabilities stay between 0 and 1, and we still have our connectives and P or P, not P. So the probability of A and probability B is A multiplied by B. A or probability B equals 1 minus A multiplied by 1 minus B, and not probability of A is 1 minus A. So how can we represent this in our ADD Lib environment? Because this is different to our Boolean logic. So what we will do is in our code, we say algebraic structure some logic equals real. Previously this would have been Boolean or bool and or not. This will not change, and implement it in here. And what we simply do is for the and, or, and not methods, our variables will stay the same, but we will change the method implementation to return A multiplied by B instead of A and B. And again, not and not A, not B, and 1 minus A. This now represents our probabilistic logic. We saw it in the previous slide. And that's all it takes to go from Boolean logic over the algebraic structure, or the probabilistic logic. We can then now generate a new Eclipse project which will now use these functions for the and, or, and not operators. So we still have the and, or, not operators in our domain specific environment. They just now have different underlying functions. And then we can compose multiple different decision diagrams, bind them into one composition called email urgent, and you can get something like this, which is a much more complicated classifier, but perhaps more valid, more useful. So let's take another example. Let's say min-max logic, which is a fuzzy logic. So now our and A and B is changed to min A and B, A or B is changed to max A and B, and not A is changed to 1 minus A. Again, we would change the same and or not operators. We're still using reals. We don't have to change that. We just have to change the functions in the Cinco to change the underlying logic. And again, we would come up with a final decision diagram such as this, which again can be a composition of multiple different decision diagrams. Again, we still have our end-to-end solution. We have just changed the underlying functions in the meta mIDE or in the Cinco section. What would change in the mIDE or the Eclipse environment is now you will be able to add in multiple terminals. This is the composition picture, but in the decision diagram folder, you'll be able to add in multiple terminals. Instead of just true false, you could add in multiple reals, etc. So you could have one predicate, two predicates. This could go here, this could go there. So we could have 1, 2, or 3 different. And then again, we generate our code. It goes over to our Java application. As we can see here, we can then compare it to, say, an optimal one that we did earlier that we can see on the left. And then we can see our own classifier. And again, the different probabilities. So again, a low-code environment, but now we can do Boolean, we can do probability, we can do fuzzy logic, and a multitude of others. So again, these are the representable algebraic structures. So you can have group-like structures, you can have lattices, and you can have ring-like structures, and possibly many more. So this is open source library. First public version put out was 2.0.0. This has actually been upgraded to 2.0.19. This is actually the current version. And if you went to the website, this is what you would get. And it's also available in Maven. So in your POM folder, you want to add in a new dependency, just add in these things. And again, instead of using .0, we want to use .19/beta version. And that would import the ADD Lib into your project. That is it for this lecture. If you have any questions, again, you can post them in the forum, and I'll be happy to answer. Thank you.